Okay, so today we're doing topic 3 in Math 20-2 or 20-3, which is volume and capacity of prisms and cylinders. Now remember, this is recalling from previous courses. Volume is the amount of space a 3D object occupies. Units are cubed, so it'd be like meters cubed, feet cubed, centimeters cubed, millimeters cubed. And capacity is the amount a 3D object can hold. Capacity, we use the units like liters, meters, milliliters, and gallons. So it's important to note that volume and capacity are related because volume might determine how much stuff that particular container can carry. Often, though, we don't fill them up 100%, so capacity is very often a little bit less than volume. And it also, just for some substances, you need a little bit of air to combat expansion. So, the cool thing, the formula, or when we look at a prism or a cylinder, what we can see is that there is a connection between the area of the base, and in this case, the base is actually its front, right? Because the prism, we would say its height would be the rectangular section, or the base of a cylinder, and the height of the prism or cylinder. So if we look at this first one, we can find the area of the base, which is 20 inches or 40 inches squared. That's 8 times 5 inches, right? And the volume is 160 inches cubed. Basically, to get the volume, it's the base times the height. So it was 40 times 4. So if we look here, that would be our height. For the triangular prism, the area of the base is the triangle, right? So we find the area of this triangle, and it's 24 centimeters squared, and we times that by the height, which in this case is 4 centimeters. So volume is base times height of the prism, the triangular prism, which is 24 times 4. Now we're going to go through this in a little more detail with more examples. Same thing happens for a cylinder. We find the area of the base, which in this case is 50.265, and the volume is the base times the height, which works out to be pi r squared h. So for a cylinder, it's always pi r squared h. So here, r would be equal to 4 inches. And and the height was 5 inches. So we can use those to figure it out. Now, this is why I like volume better actually than I like surface area. Because volume, we have basically a formula. So the general formula for any prism is volume is equal to base times height, where B equals the area of the base, okay, and H is the height of the prism, okay. So with a rectangular prism, that's going to be volume is equal to length times width times height. So if you have a rectangular prism and you have those three measurements, you just have to multiply them, and it's still the area of the base times the height. So the base is, as it was in the previous one, area of the base, okay, the big B. For a cube is area of the base times the height, and since the base is a side squared, the height will also be side, so a volume of a cube is actually going to be side cubed. So these are formulas that you can use to help figure out your things. For a cylinder, as we said before, volume is area of the base times the height. And for a cylinder, the base is a circle, so it'll be pi r squared times height. So that will be our formula. Remember, units are cubed. So it'll be meters cubed, centimeters cubed, inches cubed, okay? So don't forget that with volume. We've got cubed units. We're going to do a couple of examples together just to kind of figure that out. So if we take our first prism, our first two prisms there are triangular prisms. Now when they're triangular prisms, we're always going to make the triangle the base, okay? So this would be our base. It's the same as the other one, right? This is also, it's the exact same triangle because they're identical. So that means from this, the 12 here is going to be our height, right? And we're going to find the area of the base. Now we have to take this triangle and we need to find its height, okay? So if we're looking at the triangle, sorry, I'm going to redraw it here. And we draw our triangle in here. This is 4 centimeters. We know this size is 7 centimeters, but we actually want to find the height, right? So we need to find that. So x squared is going to equal the square root of 7 squared minus 2 squared. Now some of you are saying, where did that 2 come from? Well, it's just half of this, right? So that's a 2 there, right? 2 centimeters. So x, oh, and it's not x squared, it's just x. Oops, I keep doing that. Which is equal to 49 minus 4. So x is equal to square root of 45. And when we calculate that, we get 6.7, and it's centimeters. Okay, so that'll be the height of our triangle. So let's find the area of our base first. So B is the area of the base, which is the triangle. So that's small b h over 2, right? So that will be 4 times 6.7 all over 2, and that will get us, I'm going to calculate it, 4 times 6.7 equals, divided by 2, 13.4 centimeters squared. Now, for the second step, we're going to find the volume, which is base times height. Well, we just found the base, which is 13.4 centimeters squared. We're going to times it by the height of the prism, which is 12 centimeters, which is equal to 160.8 centimeters cubed. And that is our answer. Okay, so find the area of the base. If it's a triangular prism, then the base is going to be the triangle, and the height will be that length of the prism. So looking at this one, that means that this triangle is our base. Now the nice thing with it is, oh, no, it's not. We still have to find the height of our triangle. So we still need to find this, right? To find that height, because x will be the height of our triangle. So let's do that. We need the Pythagorean theorem. So x is equal to square root. We know that this is 12 feet. 12.5 feet, so it'll be 12.5 squared minus 7.5 squared. So when we figure that out, that adds up to, wow, exactly 100. So x equals 10, okay, and it's 10 feet. So to find our area of that base, it's equal to base times height over 2, which is 10 times 7.5 divided by 2. Let's figure that out. Now you'll see I like to split them up. Some people like to mush it all together. I like to split it up. If you can consistently get them right while smooshing them all together, that's fine. But sometimes it's easier if you've made a mistake to find your answer if you've separated it. So the area of the base is 37.5 feet squared. So the volume is going to be base times height. So that's 37.5 times, and our height of our prism would be 14 feet. So the volume would be 525 feet cubed, and that's our volume. Okay, so I tend to like to find the area of that base, whatever that base shape is, and then multiply it times the height. And I know some people just like to do it all together, and like I said, if you can consistently do it all together and still get the right answer, go for it. Now this next question says, which cylinder has the greatest volume? So we have this tall, skinny one, and then we have a short, fat one. Well, we can't really tell from looking, so we have to actually do the work. So, volume of a cylinder is pi r squared h. So, same thing over here. Volume equals pi r squared h. Now, for this one, we can just substitute right in. So, this is equal to pi 3 squared times 16, and when we do that, second function pi times 3 squared times 16, and I get 452.4, and it's centimeters cubed. Over here, I have pi, my radius here is 4 squared times 9. So, second function, pi times 4 squared times 9. And voila, dun, da, 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 they are exactly the same volume. So, I didn't see that coming, did ya? Same. So, same volume, despite one being shorter and fatter, and the other one being skinnier and taller. So it is important for you to do the work to make sure you know which is which, okay, and what's going on. Don't make assumptions. That's the lesson learned there, okay. See what we got here. Question here. Calculate the volume of this glass aquarium in centimeters cubed. Now, for rectangular prisms, I do just take a shortcut because the volume of a rectangular prism is just going to be length times width times height, because length times width is the area of the base times the height will give us the volume. So this will be 7 times 3 times 4. 7 times 3 times 4 is 84 centimeters cubed. So, pretty straightforward. I like rectangular prisms and I like cylinders. Triangular prisms, they're not too bad, but you have to do a little more work because very often you have to figure the height, you have to calculate the height, okay? Now, using the information, determine how many liters of water the aquarium can hold. So, to find the capacity. So, we have 1 centimeters cubed is equal to 1 milliliter, and 1 liter is equal to 1,000 milliliters. So, if we have 84 centimeters cubed, that means we have 84 milliliters. So if we want to find out how many liters, we have to set up a ratio. 84 milliliters over 1 is equal to 1 liter over 1,000 milliliters. So what will happen here is we will cross multiply and divide. And we remember that from our trig, right? Oh, that is not correct. I don't know what I'm doing here. We're just going to multiply. Never mind. Let's write this out. So I have 84 milliliters, and we're going to times it by, we want to get rid of these units, these milliliters. So we have 1 liter here and 1,000 milliliters here. We're just going to multiply. So put this over 1 like it's a fraction. So I get 84 liters over 1,000. Now, where did the milliliters go? Well, the milliliters divided out. So when I do that division, I'm going to change it to a decimal, and I'm going to get 0.084 liters. Okay, we'll do some work with conversion just to kind of practice that. Okay, now you have some practice work here to find the volume of the shapes below. So you need to look at what they are, figure out whether we're dealing with a triangular prism, cylinder, a rectangular prism, or if you look at number C, you've got a trapezoid. If you're dealing with a prism, it's not a rectangular prism, the shape that is not a rectangle will always be your base. So if we look at these, and it's even highlighted in C, this is your base. And here, if it's a triangular prism, the triangle is your base. For a rectangular prism, it doesn't matter because it's just length times width times height. For a cylinder, you're using that formula pi r squared h, and you're good to go. Okay, so we're going to do a little practice. We're also going to do some practice with conversions of units, just as that came up.